2.7 graphing techniques. You've probably seen the transformations before, and usually it has numbers in here, but we've got these K's. And so K and H and A, those are just numbers. And so when you see a statement like this plus K right here, that's taking the function and shifting it up by K units. And minus K is going to tell me down K units. When it's inside the parentheses, inside of the function, when it's affecting the X, you're moving it left, right, all right? And so normally people remember that if it's a positive, it's to the left. So left H, and when it's a negative right there, when it's a minus, it's right. Now, it would probably make more sense if we actually put numbers in here, but I'm just thinking of K and H as a positive integer. So I'm either going to add an integer or subtract a positive integer or, whatever. But up, down, left, right. I know you've seen that stuff before. So a little bit harder, I think, are the stretches. And if this A right here is multiplied in the front, it's stretching the whole thing. It's making it taller. That's a vertical stretch. And if it's inside the parentheses here, it's affecting the X. That's going to be a horizontal stretch. There's a negative in the front here. That's going to flip across the x-axis. And if the negative is in front of here, it's going to flip across the y-axis. Now that seems to be backwards, but if you think about it, if I'm affecting the x, if I'm changing it, moving it across the y-axis is actually affecting the x coordinate. Okay, so all that's very abstract. I'm going to make it a little bit more real, I suppose, by doing a little example here. Let's just suppose, and there's an example like this in the homework, but let's just suppose I have a point 16.8. You've probably seen this done with a function before, but I'm going to do it with a point. Okay, 16.8. Let's just say that k equals 2. And so if I've got whatever that thing is plus k, and we're going up k, then think about which coordinate is altered. Okay, am I changing the x coordinate or the y coordinate here if I'm going up by 2 units? That's the y coordinate. So just take the y coordinate and shift it up 2. That's going to make your coordinate 16, 10. Right? That's going to move that point, and that's going to go up 2. All right? And the next one, if it's going down 2, by that I mean if you've got minus k, if we're going down that many units, just look at the coordinate and take that coordinate and shift it down 2. You're affecting the y coordinate. That would be 16, 6 if it's going down 2. There's a question. There's 2 questions in the homework that's just like this. And students kind of struggle with it, so I want you to really pay attention. So then, let's say we have one that's inside the function, but it's affecting the x coordinate. So we think about going left 2. And left 2 is going to change that point to 14, 8. You're affecting the x, going to the left, all right? And so one thing that you should notice is, I know it says plus, but notice how we really subtracted over here, right? Okay, it gets kind of confusing, but just use your brain. We're going left, okay? We're going left. What ends up happening is this part right here has to be 16, okay? Because that was this right here. And so the way it works, you can think about this as being x plus 2. And so if x plus 2 equals 16, then it would make sense that our x is actually 14, all right? I know that's kind of confusing, but really think about it hard. If we're going right 2, then your 16 becomes 18. It's 18, 8. And again, if you think about it over here, if that has to equal 18, and this is a 2, I'm sorry, that has to equal 16. If that has to equal 16, and you're shifting it right by 2 units, then that x number right there has to be 18. 18 minus 2 equals 16. Okay? I think it's easier just to think about take this point and shift it to the right by 2 units, but sometimes you won't be able to do it that easily. Okay, now let's talk about the stretching. I think the stretching might be a little bit more difficult, if you can imagine. I'm going to need another coefficient here. Let's say a equals 4. So if a equals 4, then you're going to have a vertical stretch by 4. Okay. A vertical stretch alters the y coordinate. Okay. This is a multiplier after all. Look at the function. Okay. You're multiplying the y coordinate by 4. So if you multiply the y coordinate by 4, you're going to get 16, 32, because 8 times 4 is 32. The next one is a horizontal stretch. Okay. If you're going to do a horizontal stretch by 4, this one's the weird one. Okay, this is where it gets confusing, because what has to happen is, if you think about it, this thing right here has to be 16. Okay, now a was 4, so basically you have 4x inside there, and 4x has to equal 16. So if 4x has to equal 16, then x must equal what? 4. And so this point would be 4, 8. Okay. Then lastly, if we flip that point across the x-axis, okay, think about this. Think about flipping it across the x-axis. Here's your point, and you flip it over here. The y value has changed. If you're flipping across the x-axis, the y value changed. So 16.8 becomes 16, -8. And if you flip it across the x-axis, this point comes over here. Flip it across the y-axis. Did I say that backwards? The first one was flipped across the x-axis, and the y value changed. The second one is flipped across the y-axis, and the x value changes. It'd be -16, 8. All right, so go back and watch that again if you need to, but I think the trickiest questions involve that. We talk about symmetry. Symmetry for point AB on the graph. Okay, so I graphed AB right there on that graph. If we talk about y-axis symmetry, you change the x coordinate. And don't read that as a negative number. That's not negative a, it's opposite a. Because if I do y-axis symmetry, and if I show it, y-axis symmetry is going to put a point right there. And so that's not a negative coordinate. It's just the opposite of whatever a was. So you can put over here flip x. X-axis symmetry, you flip the y coordinate, flip y. So if you have x-axis symmetry, your point flips down to here, and that becomes a opposite b. You know, it's not technically correct to say negative b there. It may or may not be a negative number. If you have symmetry about the origin, you flip both. So we have negative or opposite a, opposite b. We're flipping both. And that's going to put us down. I'm going to change colors. That's going to put us down here. I'm out of room. opposite A, opposite B. How to test for symmetry. The graphical method is much easier, I think. I think I'm going to let you do that. If you just go to Desmos or put it in your graphing calculator, a lot of times if you can graph it, you can just see the symmetry. We're looking for symmetry about the x-axis, the y-axis, and the origin. The other method is a lot more difficult, I think, and it involves algebra. For the x-axis, you replace y with negative y, or opposite y, actually, and see if the result turns into the original equation. For y-axis symmetry, you replace x with opposite x and see if you get the original. For origin, you replace both x and y with opposite x and opposite y and see if the result is the original. So that's a good method, but it's going to be a lot easier if you can graph it.